Hey, this is OXDF, and today we're looking at Advent of Code 2015, doing it in Rust, and this is day 6, probably a fire hazard. Let's go ahead and look at the challenge. So there's a 1 million, we're displaying lights in a 1000 by 1000 grid, and we get these instructions from Santa on how to set it up. And so the lights in the grid are numbered 0 to 999 in each direction, and then, let's see, basically gonna get squares that we have to turn on. So if we get, turn on 00 through 9999, 999, 999, you turn everything on. There's really three instructions. There's turn on, which means set to 1, toggle, which means if it's 1, set to 0, if it's 0, set to 1, and turn off, which means set to 0. And so we're going to get a sort of a top left and a bottom right coordinate, and we're going to do a square around that, and we're going to then change the values based on the instructions. And so the answer at the end is how many lights are lit. And the puzzle answer here is that, again, if this is the first time you're seeing this video, I solved these in Python years ago. We're going back and doing it in Rust now, so we're going to pretend I don't have this answer. We do have the puzzle input here, and it's just a ton of these toggle, turn on, turn off instructions. So let's talk, I guess, strategy-wise. We're going to create a 1000 by 1000 array. We're going to init them all to 0, and then we're going to loop through the lines and update the parts of the grid as necessary. So we're going to need to parse each line into an instruction. We'll create a struct for that. We're going to have to create a grid and initialize it to all 0. We're going to have to create functions that apply an instruction to the grid. We're going to loop over all of the instructions, passing them to that function. And then we need a way to calculate the sum of all the values in the grid. So with that, let's go ahead and jump into VS Code. I'm going to use my genday script here. Oops, I'm going to try genday. I'm going to source that for day 6. And again, I went over this in detail in video 0, but feel free to go back and check that out. But it basically pulls my input.txt for me, and it creates this main.rs, which literally just reads the input into data, and basically we're done. So step 1, we need to be able to parse lines into an instruction. And so an instruction really has 3 parts. In fact, before we get into that, I'm going to grab just one of these lines from here. And because if I can figure out how to parse one of them, I can probably parse all of them, right? So we'll say let data equals, and for now, we're just going to have data be that one line, comment that out, and now we'll work on how to parse that into a struct. So we'll come up here and define our struct instruction, and that is going to have an instruction, and that'll be a string. So put a comma there, not a semicolon, and we're going to have a start coordinate, and that'll be a vector of, we'll say, I feel like when I could use a smaller, because we're going to 0 to 1000, so I need more than 8 bits. But I don't need a full view size, but we'll just go with that for now because we're not going to have that. We're not going to be keeping tons of instructions in memory, so I don't think it's a problem. And we'll do the same thing here for end, like that. And that is our struct. So now we need to parse this, and this is harder than I expected actually, but we'll use regex to do this, I think. So let's come down here and start to first let's use regex like that, and we will need to go to our cargo.toml file. Let's grab the version here, regex rust. So you can see here it's regex is version 160. They recommend just setting it to regex version 1, and that way it'll get the newest. So either of those are fine, but we'll go with regex equals 1. I think that was it. Might matter whether we did lowercase or uppercase. So maybe I'll pull that. Did I lose I lost my window. Let's see, there it is. It is lowercase. So let's set that correctly. Okay, so like that. And now we come back here to main and we save this. Let's see. Presumably we can run this. It's not going to do much, and it's going to error out because I'm importing stuff I'm not using. Let's see. Oh, we're already getting yelled at here. Okay, perfect. Undeclared use of type regex. Did I mess that up? Let's see. Oh, it's a lowercase there as well. That's why. So let's save that. There's, I have no, I ran into this when originally solving it, and I'm running into it again. That's why I let myself make these same mistakes. Oh, let's see. We're still not happy about regex. It's surprising. Come back to that one. It doesn't like having a string in a struct like this. So I fixed that by putting in a string. At some point, one of these videos, I'll do a thing on the difference between a string and an str. But for now, we're gonna try this here. Undeclared crate module regex. Maybe I just didn't save this. I didn't save this. That's why it wasn't getting updated. So you can see now it's downloading all the regex stuff and its dependencies. And now it's just, it doesn't like that we didn't use instruction. We didn't use data. It's getting all sorts of warnings, but warnings are good. It ran. So I think we're in good shape there. So next we want to write our regex to parse this. So we'll do let parser equals, and then we're going to want to do, okay, so we'll do regex new. And in here, we're going to put our regex string. And so it's going to look a lot like this. Let's grab this right here. And we're going to use, oops, I did not mean to have, let's see, let's get rid of this extra. Okay, so it's going to look like that. We're going to use something called named capture groups here. So what we can do is we can put, let's capture around this, turn off. And turn off is really going to be turn off or turn on or toggle. So now we've matched on any of those. And if we come to the front here and we put question mark P and then angle bracket, we can call this inst. And so what that'll do is that'll actually say all this stuff right here is just a label. And so anything that matches in here, I can later refer to it as inst when I'm trying to fetch it back. So we can come the same thing here and we can do this, and then we'll do P and we'll call this start. And then we got this, and we'll do \d for digit. There'll be more than one or more, and then we'll do \d again for one or more, and we'll close that. And so we've now got this capture group called start, and we'll make another one over here like this and call it end \d plus \d plus like that. Cool. So that actually looks like a pretty good. I wish I could fit it on one line. I don't know how to add white space in there without screwing it up though. So I think we've got what we're looking for there. The one other thing we have to do is this regex thing is going to return a result. And so we want to go ahead and just get the result out of there. So we'll do unwrap around this. And we will now have it. Someone mentioned to me, we'll try it. Someone mentioned to me in one of the YouTube comments that we can also do cargo format, and it will format it for us. So, okay, you can see, so it sort of wrapped the regex line into its own line and wrapped it like this. So now it looks, I guess, slightly more Rust-like. We'll go with that. So now we've got our parser regex. So we can do let captures equals parser dot captures on, what are we passing in here? Our string is data. And then now this is going to return what's called an option. Let's see. I wonder if we can get it to show us that. I wonder why it's not showing us that. I wonder if my extension's not working quite right. I found this extension to be a little bit flaky. So I'm going to disable it and reload. I'm going to come in here and enable it. Or it could just be that I'm asking it to do things that it doesn't want to do. Let's see. We can close that. Okay, here we go. Yeah, sweet. So this is going to return what's called an option. And inside an option, it's going to have captures. And so the option, it's kind of like the result up here. So we have a result that returns either the value, the OK value, or the error. Options is sort of a way of saying like it might have something, but it might not. Because when you apply a regex, you might not get results. So what we'll do is we'll put on here, we'll say parser.captures, and we'll capture the text. And then we're going to say .ok or. And so basically that's saying that either if there's stuff, and unwrap the stuff and give me the captures, or if there are no captures, say, no matches. And then that, as you can see now, it's nicely updated for us, returns actually a result. And we don't want the result. We want to go ahead and get the captures. So we'll turn, we'll call this wrap, or unwrap. And so now unwrap will throw an error if that's an error, and if it's not an error, it will return the capture. So we're actually getting back captures. Now these capture objects, what are we going to do with them? We can say, so we can do like let instruction equals caps dot, I'm going to go to a new line. Ooh, that's not what I meant to do. Let's try that again. Captures dot, and then we'll go to a new line here and do dot name. And the name we want to get is inst, because that's what we call the instruction. And if we save this, let's see, it's again returning an option. I could do the okay or whatever, but this time I'm actually going to say I can use the dot map or. And so if it's not finding, again, if this is back, now we're back to why did we get back an option? Well, we got back an option because maybe there is no inst capture group. And so we're going to return map or is going to say, well, if there is no thing, then just we can now say, give me an empty string. And then if there is a string, we're going to pass it in as m, and we're going to just do m dot as string like that. And now we've got the result here as a string. Now, if you remember, for whatever reason, we had to actually save it as a string and not an str. So we will come down here and do one more, and we'll do toString. Oops, toString like that. And now we saved instruction as a string. So we've got the first thing we need here. In fact, we can test this if we put instruction right here. And we can save this. And now we might, let's format. Okay. Look at that. Interesting. They put it all back on one row. Okay. But our instruction is turn off. So we've now, all of that work to basically say from this line right here, get the instruction is turn off. So now we'll do like let start and equals, let's do captures dot, and what are we going to do here? So this one's same kind of thing. We're going to do name, and the name is start. And if we put a semicolon there and save, we can see that's an option. We're going to do the same thing we did before and do our map or, and if it's this time, you know, again, we're going to give it an empty string for that, and then we'll do m dot, and we'll do m dot as string again to convert this to a string, because we need, right now we still have number comma number. Save this real quick. I really don't like the way it's showing us all on one line. I actually like it better if we, let's go ahead and format it ourselves here. Okay, so at this point, now we're getting a string back, and we want to take that string and we want to split it. And we're going to split it on the comma so that we get the, now we will have a split where the results are the two numbers before. So now we're going to go back to map, because again, we're going to take all our items in the split and we're going to apply something to them. So in this case, we'll map on a variable s, and we'll call s.parse. And this one we can do expect. Again, so if you remember, if you do this now, we're going to have parse is going to return results. So we're going to have a couple of results here, but we don't really want results. We want integers. So we're going to do expect, parse, if I can spell, error, not an int. In fact, we can even do, I think we can even do not an int like that. Can we save? That looks okay, but now we still are getting back some map stuff here. So I think we're going to want to do collect, and that's going to convert that to a vector. Now we're getting an error here. Let's see. Type annotations need to give a start a type. Okay, so what is start going to be? Let's go ahead and label it. It's going to be a vec of usize. Let's just for very simplicity. And I think that works. Let's see. Well, we can come down here and we put start in here. I don't think this is going to work. It's going to yell at us, right? Let's run it. So it says vec of usize cannot be formatted with the default formatter. A little trick whenever you get that, what you want to just first try is, can you put colon question mark in there, and instead of using the default formatter, we'll try to use the debug formatter, and that worked great. So we actually got back, there's our 85456. It's a vector of numbers, which is our start. So we'll grab this whole thing, go to the next line, and vec end equals, and what do we need here? We need to change this. I think otherwise it's the same. And so then we can do, we could do like let I equal I instruction, and we could like say, you know, in instruction, and then I think it was instruction we called it, start, and end. Why is that not working at all? What did I do wrong there? Let's see. Not sure what we got up here. Let's clear that out. Save this. Are we still mad about instruction? Expected a semicolon. Oh, let's see. There, is that what we're mad? No. Run it and see. This. Interesting. Let's see. I spell it wrong. Oh, I try that. Instruction. There we go. We'll get rid of that. There we go. So I was just doing it sillily. So interestingly, let's see. Let's run this. This is a point. I'm not going to go into too much detail here. It's not something I totally have a great grasp on yet, but it's important to sort of understand what this means. So as soon as we take our instruction and our start and our end and we like pass them into this struct, we no longer have access to them here. And so it's all, you can see it's yelling at us for trying to use them again. It's going to say the value is borrowed here after move. So, you know, the value is moved here into the instruction. So we've lost access to it. We can't use it anymore. And now we're trying to borrow it again or use it again, and it doesn't like that. So we can't do that. Now we don't actually want to make an instruction here anyway, and we're not actually trying to print instruction here. So let's get rid of this debug stuff for now. And in fact, we can get rid of all of this and feel pretty happy with that. What I really want to do is I want to be able to easily convert. So again, we're writing this thing to parse instructions. We want to be able to loop over instructions and parse them all each quickly. And so we're going to take this and actually turn it into a function. And what we really want to do is, let's see, we need the parser too. We need the regex too. We'll grab this. We'll grab all of that. What we really want, if you went back to, I think it was video 4. Let's check real quick. I got the results around here somewhere. Let's see. Source, was it 4? No, it was an earlier one than that. Was it 2? Yeah, okay, I think it's 2. So we wrote a thing that implemented this from vec, where we converted a vector to a present here. And what we want to do is we want to take a thing and create a from that creates from a string to an instruction. So we'll come back here and we're going to actually try to do that. And so we're going to say impl from an str for instruction. And then we're going to say a function from s, which is a str, to instruction. And then we're going to put all this in here. So now we're going to take in a string and we're going to create this parser. We're going to pax. Well, now we're going to parse on this captures on s. Ooh, is that what? Yeah, we're calling parser.captures on s to get the captures. And then we're going to run all this through and we're going to have these variables. And at the end, what we want to do is go ahead and return a instruction. And so we will generate that right here. And we can just say instruction. And now instruction here is instruction, and start is start, and end is end. And this actually will just get returned because we didn't put a semicolon here. So that's the return value for this function. So now what we can do, this gives us access to, if we come down here, we can say let inst equals, let int, we gotta give it a type because we gotta tell it what we're going into. Instruction equals, and now we can do data.into like that. And now we create an instruction. So we can come down here and we can say like inst.instruction, and we can do inst.start, Now if we come up here and run this, and we run this and we get, what did they, oh, we're never using end. Okay. But now we get, we have our thing. So we've managed to write this into function that allows us to use the from, we've written the from function that allows us to get this, turn this string into an instruction, real simple in the main loop. So with that, we can now say, okay, we're no longer going to have data just be this one. We're going to let data be all of this stuff. And we can say, we got our data, and then we're going to say for line in data.lines, like that. And now we can start to do let instruction, call it inst for simplicity, equals, we need to do, sorry, we need to do this. We thought, let's just delete this up here. Let instruction like that. And so now we're going to loop over every line, still creating an instruction object, and presumably we're going to do something, right? So we'll come in here and apply to grid. So that's what we still got to do, right? So we'll apply these all to the grid, and then we'll get down here and we'll print something out. Let's get rid of these again because we don't need those right now. Okay, so we've got we're parsing our lines. So what is next now? We need to create a grid. We could probably get away with just creating a single thing, but I kind of like the idea of doing this as a struct. So we're going to do a struct grid. And this is a kind of a cool, let's see, syntax. If we do, let's say U8, 1,000 or 100, well, let's make it 10 for the simplicity here. If we do something like this, a comma there technically, this is going to create an array. And so this might be a good time to take a break and talk about vectors versus arrays. Vectors can grow, can shrink, can change in size, and they can have varying different types of things in them. So I could have a vector, that's that. Arrays are fixed size and all the same type. So I'm going to say this is going to be an array. It's going to be unsigned 8-bit integers, and there's going to be 10 of them. Now I can change them if it's mutable, but I can't, but there's always going to be 10. They're always going to be 8-bit integers, and that's that. I can also do, let's go ahead down and do make a new function for this. So for the grid, we'll say fn new, and that returns self. In this case, we'll do a grid where grid equals, and so now we can make an array. Well, let's start this way. Where grid equals, and if we do 0 U8, that now is going to say the default value is 0. So now I'm going to have 10 zeros, all just in that simple little infrastructure, or in that simple little instruction bit right there between the square brackets. So I can do this, and then I can come down here and say let g equals grid new. So now I'll have a grid. I wonder if I can print this. Let's try. Let's print G here. I'm guessing we're going to need, let's try with the, that's not going to work either. So it's telling us that it can't be formatted using this either, but consider adding this annotation. So if we take this up here and go to grid, didn't mean to click on that. If we go to grid and put that, whoa, did not mean to do that. Let's try this again. Control-Shift-C to copy, and then right over grid, we put derived debug. See if it lets us print. It did. So you can see we've got our grid object, which contains a grid which has 10 zeros there because we initiated it to 10. Now what we actually want our grid to be is a 1,000 8-bit integers, and we want 1,000 of those. So this is actually now a 2-dimensional grid. And so we'll come down here and we have to update this to match. So we put that there, 1,000 like that. Save. I think this is, what doesn't it like there? Oh, that needs to be a semicolon. That needs to be a semicolon, save. I think we're good. If this is prints, it's going to print a ton of stuff, but there's our 1,000 by 1,000 grid is now printing. So we now have that. So we now have our grid. So let's, now that we've already got one function on the grid for new, we can do function process instruction, and that's going to take self. Let's see. Oh, it's going to take, yeah, pointer to self, because we always pass a pointer to self. And then it's going to take, which I guess doesn't need a type. And then we can do inst instruction, like that. Okay, so we're going to take in an instruction, and we're going to take in itself. And so we'll do for x in inst dot start dot 0 dot inst dot end sub 0, like that. And actually, I think, let's see. So if we're going, that's going to go, so if like end, if we want to include end, we actually need to put a +1 on here, because it's going to stop the loop when it reaches end, and we won't actually include end. So we put that there, and then we can do for y. Actually, we should do rows and columns. It's probably easier to think about it. So this is our for row in, for r in that, and we'll do column for column in inst dot start dot 1 inst dot end dot 1 plus 1. Okay, so now we're going to loop over our square created by the instruction, and we're going to do match inst dot instruction and like that, and we can do turn on like that, and we'll do self dot grid sub x, not x, we're doing row sub column equals 1. What don't we like about this? Expected string found string. Oh, okay, so we need to do self dot string dot this, and we do as string, like that. Okay, now we'll do turn off self dot grid sub r sub c equals 0, and then we'll do toggle, and we'll do self dot grid sub r sub c, and now we're going to say that's equal to self dot grid sub r sub c plus 1 mod 2. And by the mod 2, all that does is basically, if it's 0, plus 1 becomes 1, 1 mod 2 is 1. If it's 1, 1 plus 1 is 2, 2 mod 2 is 0, so it changes it back. So we've got our, effectively, our toggle. And then we have to give it a base case. And in that case, we do not expect to find any other instructions. That'd be very strange at this point. So we'll say unexpected instruction, like that. And then, oops, and then we'll do comma, inst dot instruction. Comma there. I think that looks good. So that's, I think we have our process instruction function. Oh, we don't like something in here. Okay, what don't we like? Cannot assign to self, which is behind a, consider changing this to be mutable. Oh, okay, of course. So we need self, we need to be able to change self in here. So we'll just put mute there and save that. I think all we're complaining about now is the fact that we don't call process instruction. So let's come down here and we can do, have we created a grid? Oh, we created a grid, but we created it too late. Grab this, move it up here, make our grid, and we'll say g.process instruction on inst, and put a semicolon there. And now, what do we print when we're done? We need to print, so that if that runs all the way through, now we need some way to print out the sum of all of the light, right? So we're just gonna need another function. We could run this, make sure we don't error out, print a lot of zeros again. Huh, why do we not, maybe we didn't save. Yeah, okay, save. Oh, and now we don't like this. What don't we like? Cannot borrow G as mutable. It must be declared. Oh, okay, we gotta make G mutable. That's fine. for line, and this should be line into. So data gets passed in read through in lines, line into, process instructions. Let's run this again. It told me like, I don't know how that got set up that way, but let's get rid of view. Run that. Okay, we're seeing, I mean, I'm looking at this, I don't know that it's right, but I'm looking at this, I'm seeing a grid with lots of ones and zero, with like blocks of ones change. So it's like promising. Let us see here. So what we need last is we have our grid right now. We can create it. We can process an instruction, apply an instruction to it. And we need some lights. And what are we going to take in there? So we're going to need our self for sure. I think that's it. And that's going to return a U size like that. And so what are we going to do here? Well, we're going to do, I'm going to try something a little, we could do the same kind of loop over here by like looking at that. This is, summing up in a two-dimensional array like this is surprisingly hard. Actually, I was talking to Epi about this, and he basically said he recommends this fold function, so I'm going to use that. He said it's something he's used several times in the advent of code last year, but never anywhere else. But it's a good tool to have in our toolbox, I guess. So what we're going to do is we're going to do self.grid. And we're going to do, so we'll do .iter. Now we turn this into an something we can iterate over. And now we're going to use fold. And fold's going to do is, well, here, they tell us, it's going to take every element into an accumulator variable by applying some operation to get it. So the first thing we pass in is what we want to initiate our accumulator at. So we're going to start it at 0. The accumulator is going to basically be where we sum. And then we need to pass it, okay, so we have our accumulator variable and our row, right? Because we're iterating over these 1,000 rows. And then for that, we're going to actually fold again. So we're going to do the accumulator plus, and then we're going to do the same thing. We're going to row.iter. We're going to fold on, make this row. And then we're going to fold on that. And again, this time we're going to start an accumulator at 0. We'll call this inner accumulator and cell. That's our two things we're passing in. And then for that, we're going to return inner accumulator plus cell. I don't think this is going to quite work. It's going to have some errors, but we'll try to work through them. But in theory, what we're doing here is we're taking the grid, we're iterating over it. For each row, we're going to fold. So we're going to start at 0. And then for each one, we're going to add in. Well, for each one, we're going to take the accumulator from the last one. So it'll start at 0. And then after we add in the first row, it'll go up to whatever it is. And then after we add the next row, so basically it's just sort of keeping track across rows. And for each of those, we're going to add in this next thing, which is another accumulator. So it's for the row, it's going to go across and add all the things. Now we're going to have type problems here. You can already see this. Our cell is a U8. And so we're adding together two U8s. That's fine. Although you can see this is a pointer to a cell, and this is a U8 itself. So we probably want to come in here and do that. So now we're adding together two U8s. But we're still going to get some type errors. Let's first, just so we don't have to see it anymore, let's put this here. So we don't print the G anymore, and we'll run this and we'll see what we got. So we see right away, there's no implementation for adding a U size plus a U8. We need to get to a U size. So, because a U8 is not going to be big enough to hold our sum of all our lights. So what we're going to do here is we're going to say, okay, we got this U8 and this U8, and we're adding them together. Right away, we actually might have a problem. Well, we know our values are always 0 or 1, so we're going to be okay there. But we really want the accumulator to be a U size. So let's just type this as U size, and we'll have to do the same thing out here as U size. So now we've sort of forced everything into being U sizes. Did I fix it entirely? Let's try running it now. So applying all the instructions takes a second, and we never use sum lights, but let's come down here and we can do g.sumLights and run this. And not only do we get a value, we get the right value, I believe. If we check here, 400, 410, 400, 410. So that's awesome. Hopefully that makes sense. There's a bunch of little tricks in here and places to get caught. And this took me way longer the first time, a lot of struggle. But hopefully it's useful. You can learn from my mistakes. So let's go check out part 2. It's taking longer than I expected already. So it turns out the short answer is they're basically saying completely change how you interpret turn on, turn off, and toggle. Now, not all your lights are, your lights are not just on or off, but they have a brightness value of 0 or more. All the lights start at 0, turn on +1, turn off -1, and toggle actually means increase by 2. And so they want to know the total brightness. So I think we've actually set ourselves up really nicely here for this. All we need to do here is let's go ahead and create a new grid. So we'll go let mut g2 equals grid new. So now I've got a new grid, and we still can use the new function just the same, and we can still use the sum lights. Our sum lights works great actually. What we need is a new process instruction function. So we'll come down here and we'll call this process instruction 2. And we're going to do the same sort of looping, except for now turn on means plus equals 1. So add 1 to that. Turn off, we want to do minus equals 1, but we got to be a little bit careful because we can't have negative. It says 0 is the bottom. So what we really want to do is we want to say put this in, wrap this a little bit in a thing, and we can say if self.grid r.c is greater than 0. So if it's already greater than 0, if it's 1 or more, and then we can do subtract 1 like that. There's probably we could probably do this all in one line, but let's make it really clear to read. And then toggle, we just need to do this. In fact, we can just do plus equals like that, plus equals 2. So now we've got our process instruction 2. So we can come down here and say g2.process instruction 2 on our same instruction. So we're taking this instruction, we are processing it, we're processing it again, and we are going to come down here and we can do g2.sum lights, and that will give us the answer. Now I'm already catching a mistake, something that's unhappy here, and it goes back to something we talked about earlier. Let's look at the error. So value is moved here. So I pass instruction to the process instruction. Now, when I was just looping over and having one grid to worry about, cool, I'm done with instruction, I never have to use it again. But here I'm trying to use it again, but I've given up my rights to it. And so the real simple answer here actually, and this took me longer to figure out the first time, is to come up here and say, we want to make this, we want to actually pass this by reference. So we're going to pass this as pointer to instruction. And we can effectively do it here too. We don't actually have to, because once we use it in process instruction 2, it's gone. But now if we save this, we can run this, and let's see. Oh, I put that in the wrong place. Let's try that again. That is a pointer to an instruction, and that is a pointer to an instruction. Clear that. I think that looks good. Let's save. Okay, that looks good. Run that again. And then let's see, we need to we need to actually pass these as pointers now, because it's expecting pointers. So we'll come in here like this. Now we call it, and I think we're going to be good. 15343601. 15343601. We got it. Okay, so that run part 2 is much easier since given we set up part 1 very nicely. There's one last thing I wanted to talk about before we move on. Epi reached out to me, friend of mine, the creator of Pharaohbuster, very good at Rust, reached out to me after I published video 4 and mentioned to me, like in that one I was taking 30 seconds to run when I was running cargo.run, and he said, you should really try it with the -- release. And in that one, I went back and tried it, and using release took it down from 28 seconds when I ran it with debug, just normally cargo run, down to 6 seconds when I ran it that way. So I thought it'd be interesting to show you all that time difference. So let's run this here, and if I do time cargo run, you can see it takes about 3 seconds. We can run a couple times and just check it out. But it's basically 3 seconds to run this like that. If I add release here, this first time it's gonna have to rebuild some stuff, so we're gonna let it's re-downloading all the stuff, so let's not count that. But now I'm running in less than 1/10 of a second. We can run that again. 0.08, 0.079, 0.082. You know, that is amazingly faster. So we went from 3 seconds down to less than 1/10 of a second, so 30 times faster. And when you build with the release, so with the debug, when you build debug, which is without the release flag. You are building in debug stuff. You're not taking all these compiler optimizations. It is just building it almost in a way that you're meant to go in and run it in GDB or look at it that way. Look at the assembly, figure out what's going on. When you run it with a release, it's taking all sorts of optimizations, and it makes a huge difference. So, certainly if you're ever pushing a package out to public, Epi says when he pushes Pharaohbuster out, the number of threads it's able to run while it's brute forcing, goes up by factors of 10. If he needs to make sure when he puts that release up on GitHub that people are going to download, that he's using the release flag to put that out there, because it's going to run faster. So maybe from now on, I'll just always add the release there and we can see it, unless we're going to actually dive in and debug it in some way. So, all right, I've talked a long time. Thanks for sticking around with me till the end. Hopefully this was useful to you, and I'll talk to you next time. Thanks, bye.